Okay, so carrying on with our midterm review problems, John Marsh here, and I am starting with problem number 17. So we've got the last page of problems here, and I'll go through as many of these as I can in this video. So starting with number 17, and basically it's asking us to do a Venn diagram to satisfy all of these conditions, and that's why there's ands in between them, because when you put ands in between it means they all have to be true. Okay, and so each part, A through F, requires a Venn diagram. And so let's start with part A, and we need to have, and I took out the and symbols here because I think they just made it look more complicated. So I need all three of these things to be satisfied. B's got to be a subset of A, C's got to be a subset of A, but C intersect B is the empty set. In other words, B and C don't intersect. No elements in their intersection, meaning we draw them separated like this. And so both B and C are subsets of A because they're inside of it, and their intersection is the empty set because they don't intersect. Okay? For part B, we need B to be a subset of A, we need C to be a subset of A, and we need C to be a subset of B. And so I can just put C inside B, B inside A, and I've satisfied all these conditions. As a matter of fact, if I just satisfied conditions 1 and 3, condition 2 would follow from that. If B was inside A and C was inside B, then it would necessarily follow that C would be inside A. Okay, I didn't even need to give you that middle one. Okay, so A, B, and C. Okay, for part C, we want B to be a subset of A, we want C to be a subset of A, but we don't want their intersection to be the empty set now. And so all I have to do is put both B and C inside of A and make it so that they overlap each other. Now their intersection is not the empty set, because by the fact that they overlap, because there's some area in that intersection area, because there's an overlap, that means that it's representing that it's not empty. Part D. B is a subset of A, C is not a subset of A, and C is not a subset of B, but C does intersect with B, meaning that C intersect B is not the empty set. And so I'm going to draw B on the inside of A, and I'm going to draw C not being a subset of A, so it can't be completely within A, it can't be completely within B, so C has to reach out, but it also has to reach in and overlap with B. And that's what it does right here. Okay? Part E. This one was impossible. B being a subset of A, C being a subset of B, but then C not being a subset of A? That's impossible. Okay, hopefully that was obvious, but I did mark it down on the note in the announcement in Angel. Okay, again, and so it doesn't even matter whether C intersects B. If C is a subset of B, well, one way or the other, this is impossible. We can't satisfy this condition when these others are true. And that goes all the way back up to this case, where I said that C being a subset of A follows from the fact of both of these. In other words, if C is a subset of B and B is a subset of A, then C is a subset of A. That's a true statement. Okay? And so this is impossible because it says C is not. Part F, what we're going to do is we want A intersect B, and we want A to intersect with B. Their intersection is not the empty set. We want them to intersect. We want them to overlap. We want B and C to overlap. We want A and C to overlap. So we want all three of them to overlap, but we want the triple overlap, A intersect B intersect C, to be the empty set. In other words, if we draw it like this, we've got everybody overlapping, but we've got this problem in the middle in that we're supposed to have the empty set where all three of them overlap. And so you have to kind of draw it. You can't draw it as circles because the circles will always have an overlap in the middle. So you have to draw it you have to draw C so that it intersects A and B but does not cross that overlapping point. Okay? So that's problem 17. So this is not right, but this one works. Problem 18. Basically, it says use Venn diagrams to show 3 sets in the most general configuration. Shade in the area indicated. Each part gets a shaded Venn diagram. Okay, so I'm going to shade in all these areas. So let's start with the top. I'm going to draw the same, I call it a drum kit, the 3 overlapping sets for each. And I'm going to start with A union C, and that means the A and C are both shaded in, the union. Unions are easy because you just shade in one side of the union, then the shade in the other side of the union. Intersections are a little bit trickier because you have to look beforehand. You can't just shade in B, all of B to start with, because we're only going to shade in B intersect C. So here's where B and C overlap. That's their intersection. B minus A, here's B, where I've subtracted out the part where A cuts into B. And we're totally ignoring C in this one. In the one up here, we're totally ignoring A. Okay, here's A union C minus B. We had A union C up here, and if we subtract out B, we're going to cut out the part right here like this. So here's A union C minus B. This one, part E, it says A minus B union C minus B. Okay, so we can, with a union, you can just shade in the left side and then shade in the right side. Here's A minus B. Here's C minus B. So it's the union minus B. As a matter of fact, A minus B, we can prove union C minus B is equal to A union C minus B. And that's what exactly what we've got here. We've got A union C, and we cut out the part where B overlaps it. Here we have A intersect B intersect C. This is the triple intersection right in the middle. Here we have A intersects B minus C. So A intersect B is this little football shape here, and we're just going to cut off the part from C. Okay? Finally, this is the trickiest one. A intersect B minus C. So we're going to do the little football and subtract out the middle on all 3 sides. ABC, BCA, CAB. In other words, we've rotated the A and the B and the C around. And this one, so A intersect B is up on this side, and we're subtracting out the triple overlap, the part where C cuts through it. B intersect C is on this one, and we cut it off there. And C intersect A is this one, and we cut it off there. And if we union those 3, we get all 3 of these little segments here. So that's problem number 17 and 18, and I'll do 19 in another video.